Hello, welcome back to Story Chronicles. In today's video, we will explore the Linux Iostat command. Iostat command in Linux is utilized to observe CPU utilization alongside the input-output metrics for storage devices and their partition. It enables administrator to evaluate disk performance and detect potential I/O input-output bottlenecks within the system. Before we get started, don't forget to subscribe to my channels, hit notification bell, like, share, and comment. Iostat provides insight into CPU usage, monitors read and write operation on disks, show data transfer rates for input-output activity, reports how heavily each device is being utilized. So let's check if we have Iostat in our system. Yes, we have. Maybe you're needing to install Iostat in your system. You should install sysstat package. Iostat command include in that package. So in Red Hat, you should execute sudo yum install sysstat. Okay. On Debian, you should implement sudo apt get install sysstat command, and this command will be installed package on your system. Let's execute iostat. Let's clear the screen first. Iostat. The resulting output is organized in the primary section. The average CPU section here provides high-level view of how system resources are being utilized. The user indicates the portion of CPU time consumed by user space non-kernel processes. In this case, it is 3.87%. Nice. Reflect CPU time used by processes with adjusted priority with nice value. Here, 0, meaning no prioritized processes are active. System. Show the percentage CPU time spent executing kernel-level operations. In this example, it's 0.92%. IOWAIT represents the time the CPU is idle while waiting for input-output operation to complete. Still, indicates time lost to the hypervisor in virtualized environment. So this is 0 because there is no noticeable connection from virtualization. And idle in percentage. Display the percentage of time the CPU remains idle with no pending work. Here it 95%, showing that system is largely underutilized. The second part, this part, device section, device utilization report. The device section represents detailed input-output statistics for each storage devices. Device. Identify the disk or partition. In the example, entries include loop 0, loop 1 until loop 9, and physical drive like STA. TPS indicated the number of input-output operation transfer per second. For instance, STA, it shows 7.59, reflecting active data activity. Kilobits read second, display the rate of data read from the device in kilobit per second. Kilobit written second, show the write throughput in kilobytes per second. KB DSCD, discard second, represent the rate of discarded data per second, so there is no discard in our system. Kilobit read, total volume of data read from device size monitoring began. Kilobit written, total amount of data written to the device. Kilobit discard, total volume of data discarded data. The Iostat have different options. One of the Iostat option is -h or --help. Let's execute. Clear the screen. Iostat. H. These options display the help information. Sorry, help. Okay, let's clear the screen. So Iostat help. This option displays the help information and then exit. It shows the command syntax along with all available options for Iostat. Here you can see all available options. Next, Iostat -X. These options enable extended input-output statistics, providing a more granular view of device performance. It is particularly valuable for in-depth analysis and diagnosing disk-related bottlenecks. So, from the output, average CPU, display overall CPU usage metrics. Devices part shows the list of monitored block devices. Let's zoom in. Here you can see how it's constructed. Util indicate the percentage of time the device is actively processing input-output requests. Number of read requests per second issued to the device. RKB seconds. Amount of data read per second. RQM second. Number of merged read requests per second. Kernel combines adjacent read. RQM. Percentage of read requests that were merged. High value equal to good input-output optimization. Wait. Average time millisecond for read request to complete. Includes queue time plus service time. Rerec-SZ. Average size of read request. Large value equal to sequential reads, small random reads. Here write metrics. WS. Number of write requests per second. WKB. S. Amount of data written per second. WRQM second. Number of merged write requests per second. WVRQM. Percentage of writes merged before reaching disk. Wait. Average time for write request to complete. WERQSZ. This one. Average size kilobyte of write request. Discard metrics. Discard per second. Number of discard requests per second. This one. Discard kilobyte second. Data discarded per second. DRQM-S. Merge discard request per second. DRQM. Percentage of merge discard request. Wait. Average latency for discarded over operation. Direct SZ. Average size of discarded request. And here flash metrics. FS. Number of flash requests per second. Wait. Average time for flash operation. AQ size. Average queue length. How many input-output requests are waiting. And utilization. Percentage of time the device is busy. 100% disk is fully saturated. Low value disk mostly idle. Let's clear the screen. Iostat XD. When the X option is used together with D -D, the command output details input-output statistics specifically for storage devices, omitting CPU-related information. Clear the screen. Iostat -C. This option limits the output to CPU-related metrics, excluding any device input-output data. It shows key utilization fields such as user, system, idle, and other information. -D. Display only device disk statistics without CPU information. Iostat -K. This option forces Iostat to present throughput metrics in kilobytes per second rather than default block-based unit. -M. These options configure Iostat to display throughput values in megabyte per second, which is more readable when working with high-volume input-output systems. Iostat Iostat minus P. This option extends the output to include statistics for block devices along with all their associated partitions. If a specific device is specified, Iostat will display data for the device and each of its partitions. Let's clear the screen. Using interval and count, you can collect Iostat statistics at fixed interval by specifying additional parameters in the command. Let's execute. Let's bring example Iostat minus k 2, 3. This command shows CPU and device statistics in kilobytes, refreshing every 2 seconds and stops after generating 3 reports. Let's see. 1, 2, and 3. 1, 2, 3. Generates reports every 2 seconds and stop after generating 3 times. So that's all for this lesson. Don't forget subscribe to my channel and hit notification bell. Thank you.